Hi. Hi, everyone. My name is Rohan Kayan. This presentation is for my reading of the paper, which is SemEval 2018, Task 9, Hypernym Discovery. As part of this presentation, we will be covering the introduction, related work, research, and what are the findings. This paper mainly talks about competition, which is done as part of SemEval 2018 for the hypernym discovery. This paper talks about how hypernym discovery has been a binary classification task at that point in time, and then most of the hypernym discovery has been treated as that if the pair of text they have the hypernym relationship between them or not, whether it's either yes or no. This paper reformulates that assumption and treat it as a graded value for the hypernym discovery. Also, it talks that whenever we give a certain corpus as a target corpus, finding the hypernym relationship is better, and that is the base of this competition. Now, talking more about what is hypernymy, and its importance. This is the capability of relating a generic term and the classes to its specific instances. Now, given an example, we can talk about is a relationship like dog animal. Now, there is a hypernym relationship between dog and animal. In the same way, there are some entity relationship where we can say that one thing is instance of another thing, like Rome is a city. So Rome is an instance of city. So these both the relationship are like hypernymic relationship, and these are like very important tasks for the NLP related tasks, like question answering any application. Finding out the hypernym relationship between the text helps enormously. The ontology, semantic networking, and taxonomy. So it's very important part of the NLP study and research. Now, related work has been done. Mainly, there were two approaches at that point in time. One is the pattern base, in which it is kind of a supervised learning where you have a given textual corpus, and based on the occurrence of the pair of word, we find out whether there is a hypernymic relationship between those pair or not. It has high precision, but it has lower coverage. Now, the another approach was a distributional approach, in which based on the there would not be a co-occurrence, explicit co-occurrence of the pair, but based on the distributional properties, we can find out that where there is a hypernymic relationship between a pair of object or not. And we can also divide this as a supervised and unsupervised approach. Now, this paper talks about mixing both these approaches and getting a better efficiency. Now, talking about the task, this task, as I mentioned earlier, involves giving a target term, a different source, and related to that vocabulary for that domain or the general purpose, and then trying to find out what is the accuracy of finding hypernym relationship. Now, to make it generic, they divided it into 5 subtasks, 2 for the general purpose hypernym discovery, and 3 for the general purpose hypernym discovery, and 2 for the domain specific hypernym discovery, which is like medical and musical. So here the corpus, the source corpus will be different, and the vocabulary for medical and music will be different. And now when you have given a term, you have to find out, you have to do the discovery. Now, earlier approaches, it was generic. There was not given a specific corpus, and this task talk about the specific corpus. Now, the paper talks in length about the different phase of how to prepare data set, how to create the gold standard. Now, how they have collected the data, how they have come up with the corpus compilation, vocabulary creation, and then finding out the gold standard, how they have, for the gold standard, how they have done the hypernym discovery, and how they have done the Hypernym validation, which is like very detailed for each step, which give you a high level idea that how, if you prepare for any competition, how you prepare a data set and how you make sure that what is the baseline, how to come up with the gold standard. So all those aspect of competition has been covered very well. Now there are two evaluation metrics which are captured for evaluating the different systems. One is the mean average precision, which is like out of 15 terms. So one thing which I forgot to mention, that here we are not capturing one hypernym relationship, but we are trying to grade 15, or the system is trying to find out 15 hypernym relationship and trying to grade them. And this is like the average of precision of all across different sample experiments. And the second is mean reciprocal rank, which is MRR, which gives that what is the rank of your first correct result. So now you have found out a correct result, but what is it ranked 13th or 12th or first? So based on that, this evaluation matrix comes in the picture. Now there are so just some fun facts that there are 11 teams participated for this competition, and they have submitted around 39 systems. Now, as part of this paper, they have, the author has already prepared some baselines, and you can see the baseline on the bottom of the table, and whether they were supervised or not, that we can find out with this the supervision column. And these are the 11 teams which participated, and whether they are supervised or unsupervised, those are informed here. Now, after running these tests, these were the results of those systems. Now you can see that MAP, MRR, there's another attribute which they have captured is like the false positive, which this attribute is like this evaluation matrix is to capture that if there is some mistake in the gold standard, whether the system is able to capture it or not. And the baseline you can see with the asterisks and how system has performed for the baseline. Now the two columns are like concept. As I mentioned, this concept relation is a relationship, like dog is an animal, is a concept. And entities is the instance of relationship, which is like the example which I gave earlier is Rome is a city. And now averaging out those things. So we can see that CRIM, that system has outperformed baseline for the supervised system. And for Italian, Sparsons has done a very good job, and similarly for different languages. Here again, you can see that for the domain specific, CRIM has surpassed the baseline. For entity, this Parson has given a very good result. Now, after looking all these results, the conclusion was, though the task was very challenging for all the systems, and that leaves a lot of room for improvement, but it is clearly shown that that the supervised systems have been outperformed the unsupervised systems. And the CRIN system, which has like outperformed in most of the category, it combines the supervised modeling and unsupervised modeling, and it is actually using the neural network architecture. And so as part of the paper, the idea was that how can we combine the supervised and unsupervised learning to do the hypernym discovery. And this paper actually, the idea was to this paper will help in the future improvement in the hypernym discovery field. Thank you, everyone. And here I will conclude my paper presentation for the paper.